Hello, I'm Hanbyeol. I would like to talk about our work named Characterizing and Quantifying Expert Input Behavior in League of Legends. There are several reasons why we studied input behavior. The first one is that input behavior have a significant impact throughout the game. This game is League of Legends, one of the most successful recent esports games studied in our research. The game takes about 25 to 30 minutes to finish, and during that time, 5,000 button inputs and more than 2 million mouse pointer movements occur, requiring so much input that the logging data reaches 20 megabytes. Therefore, if the player can operate the mouse quickly and accurately as shown in the video, they will be able to play the game at a significant advantage. That's why we analyze input behavior. Additionally, LOL players are very interested in input behavior to improve their skills. The picture below is some word cloud created by topping modeling by crawling 447 posts from the community site Reddit. Look at keywords such as mouse, click, micro, mechanic, improve, help, and guide. We can find that they are interested in input behavior. So why has not input behavior been analyzed well until now? There are several problems. The first is that it is difficult to collect large-size input behavior data. As mentioned earlier, input behavior data is difficult to collect because it has high spatio-temporal resolution. The second problem is that input behavior itself is difficult to interpret and quantify. This demo video visualized the mouse and keyboard logging data we collected. Two players with different expertise are doing mouse and keyboard input. Do you feel like there is a difference, or which one seems to be a professional player? The left side was a professional player and the right side was a novice player. It is difficult for people who have seen that video to clearly explain the difference or quantify what and how much the difference is. Lastly, even if we analyze input behavior, we cannot be sure whether it helps players train to improve their skills. To address these problems, three research goals were established. First, collect a large amount of data in an ecologically valid setting. Then, characterize and quantify expert input behavior for interpreting and measuring. Lastly, we want to verify whether our findings can provide actionable lessons for esports players. We conducted research by constructing a holistic pipeline of 3 steps to achieve our goals. Step 1 is a qualitative study that interviews experts and qualitatively analyzes them to extract input skills. Step 2 is a quantitative study that quantifies input skills, collects data, and analyzes input behavior. Step 3 is a longitudinal study that designs training aid software that visualizes input skills and conducts 3 weeks of training. In the first step, we characterize input skills through interviews with experts. Our qualitative study was conducted according to the following procedures. We recruited and interviewed professional players who were familiar with expert input behavior. Based on the interview transcript, we performed semantic analysis and extracted input skills. Interviews were conducted with 5 top-tier experts, and all participants were professional players or coaches. We tried to recruit a diverse group of participants with the highest level of expertise. We conducted a semi-structured interview asking about expert input behavior. The interview was conducted by asking the following questions. Each question is designed to help interviewees recall expert input behavior in various situations. We ask about situations such as moving and attacking champions, translating or switching the screen view, and communicating with teammates. We also ask questions about the situations in which players move the mouse and press buttons. Based on the interview transcript, we performed semantic analysis to obtain clues and themes. As a result of semantic analysis, the following input skills were obtained. I would like to briefly explain 8 input skills. The first is the positioning skill. In LOL, players can move the champion by left click, but we must click in several places to make it difficult for the opponent to predict our movements. In LOL, players must click a lot, and if they move the pointer quickly and click, the probability of failing to click increases. Therefore, it is the risk compensation skill that requires multiple clicks to compensate for the risk. In LOL, translating the player's local camera view by moving the mouse pointer to an edge is called edge panning. At this time, the edge panning skill is that region of interest must be located in the center of the screen to avoid edge panning multiple times. When moving the mouse pointer, movement of the pointer without corrective movement to the desired point is a motor execution skill. In LOL, players can press various buttons to attack and use skills, and in this case, familiar with more diverse combos is a chained input skill. In addition to translating the local camera view, the player can switch using various commands. Monitoring skill is to understand the situation of team members by switching views frequently. It is important to do a lot of view switching, but since players must also control their champions, it is also important to quickly return to the main view where their champions are located. Visual processing skill is quickly processing necessary information and returning to the main view. In LOL, players can communicate with their teammates using smart ping as shown in the picture. Active communication skill means a lot of communication with team members. The second step is a quantitative study that collects and analyzes a large amount of data. The quantitative study procedure is as follows. Mouse and keyboard logging data is collected in ecologically valid settings. Then index calculation algorithms calculate the data to obtain 8 input skill indices. Through this, we analyze what differences there are between novices and experts. The index of input skills measures how close to the input behavior recommended by interviewees. We designed 8 indices for 8 input skills. Among them, to explain one index called the positioning skill index, the experts said that players should move unpredictably to avoid attacks from enemy champions. Therefore, we designed an index that measures the angle of vectors created by successive clicks as shown in the picture on the right. The next index to be explained is the edge panning skill index. In the interview, it was said that after edge panning, the region of interest should be closer to the center. Therefore, we measured how close the click was from the center after edge panning. Because the closer a region of interest is to the center, the more likely the click will occur there. We collected data about 5,000 matches from about 200 participants. We collected data containing input behavior data and in-game performance statistics such as kills and deaths. Below is the data acquisition software. Almost everything is automated. Because the collection process did not disrupt the participants' gaming experience in any way, we were able to collect a large amount of data. Participants were divided into 4 groups or levels according to the ranking system that exists in LOL. All 8 indices were calculated for each match and averaged for each participant. That is, all participants have one average value for each index. We then conducted a one-way ANOVA to analyze whether there were differences in the indices. Depending on the direction of the arrow, the higher or lower the index value, the closer it is to expert input behavior. In all input skill indices, we can see that as the level increases, they tend to input closer to the expert input behavior described by experts. The final step 3 is training based on our indices. Here the software for training and the 3-week training study are described. The software used for training visualization contains a total of 7 information. In addition to the results of the input skill index, it also includes information on in-game performance statistics. The first type shows how the input skill index and performance statistics changed over match. The following type shows how each value changed over game time. Users will be able to evaluate things like concentration over time. The following is a radar chart that shows how each value excels or falls short on average compared to the comparison group. Differences from a comparison group can be discussed to bring about behavioral change. The last one is the correlation between the selected input skill index and performance statistics. Coaches can talk to trainees about things that seems to be correlated and what behavioral changes are needed to improve performance statistics. A total of 10 academy students and 3 coaches participated in the 3-week training using this training aid software. As shown in the training schedule below, students repeatedly played the game and received coaching based on the results. Coaching was conducted with the goal of reducing the gap between trainees and the expert group, that is the level 4 group. Therefore, to verify whether the training was effective, we evaluated how the initial differences between the trainee and expert groups affected their index changes. This is an illustration to explain delta x corresponding to the x-axis value. This is a radar chart showing the index values of the comparison group and trainee. The difference between the comparison group and the trainee is delta x. Delta x is the value that trainees must reduce to become like the expert group. The next thing to explain is delta y, which corresponds to the y-axis value. Delta y is the weekly difference of the index. This figure is the later chart showing the index values of week 2 and week 3. As you can see in this figure, delta y is the value of how much each index changed in the next week. In this way, we verify the effectiveness of the training by assessing whether initial differences from the comparison group resulted in behavioral changes. This is a scatter plot and the result of linear regression showing behavioral changes according to initial behavioral differences over 3 weeks of training. In other words, it indicates that students recognize their shortcomings and how much effort and change they made to improve them. Here we can see their efforts to change their behavior, although not statistically significant. Lastly, to summarize, a 3-step holistic pipeline of input behavior analysis in League of Legends was presented. Large amount of LOL input behavioral data was collected in an ecologically valid setting. By characterizing and quantifying expert input behavior, 8 indices were designed and correlation between indices and length were shown. By training through visualization of input behavior, LOL players may be potentially provided with actionable lessons. Thank you for listening.